In today's session, we will be studying about the population forecasting methods adopted in water supply projects. Population forecasting is a process of estimating future population of a city or town for selected design period. It is essential to obtain water demand of a population for designing of intake wells, treatment plants, reservoirs, distribution network, pump, etc. Population forecasting is the process of estimating the future population of a town or city for selected design period. In water supply engineering, forecasting of population is essential because all components of water supply systems such as intake structures, treatment plants, reservoirs, pumps, and pipelines are designed based on future population and corresponding water demand. The design period generally adopted in India is 30 years. So we estimate the future population based on the various methods given in the Indian code or practiced worldwide to reach at optimum water demand at at the selected design period or intermittent period for designing of various components. So we can estimate if a city has water demand of 78 million liters per day in 1961. Then with the process we estimate what would be in 2014. We found that it is in 410 million liter per day. Based upon this million liter per day, we design our intake wells, treatment plants, pump stations, water reservoirs. It may be overhead or ground level. Then pump stations, water mainline, and distribution networks. So, need for the population forecasting, estimation of water demand with the population forecasting per liter per capita per day. We know the water requirement of various components. रेजिडेंस में कितना यूज होगा, होटल्स में कितना यूज होगा, यूनिवर्सिटी है तो कितना यूज होगा, हॉस्पिटल से कितना यूज होगा, लाइफ स्टॉक है कितना, इसका पूरा IS 117 टू 1993 में दिया गया। वहां से हम लोग we know the population, we know the per capita demand of the population, then we know how much water will be demanded at different period of the selected design period. Based upon that, we design different components for the optimum utilization. Like reservoir, we can design for 10 years. Again, for the 20 year, we can have the provision, financial provision accordingly. Pumps for 15 years, or water distribution network for developing town. We can design in phases. So in design of treatment plants, say today it is 74 million liter per day. Maybe after 10 years it will be 210 million liter per day, and after 30 years it will be 410 million liter per day for that population. So we can design accordingly in phases. Design of storage reservoir, design of pipe network, and planning future city expansion. If some city is coming up which have the future potential of industrial growth, then accordingly we can make provision at the beginning itself. So method of for the population forecasting, we generally for the old and developed town like if say Varanasi, Allahabad, Madurai, or those towns which has already been attained optimum, we go for the arithmetic increase method, in which from past 4, 5, 10 years we average the population growth and then add with the uh, decades which is going to come or years which is going to come. So we will study about this. Then geometric increase method, the towns which are increasing, growing, for that we adopt the geometric increase method. It is like a compound interest, calculation of compound strength. Then incremental increase method, it is combination of arithmetic and geometric increase method for the average Indian towns, decreasing rate of growth saturated cities के लिए, and logistic curve method, large cities reaching saturation. So these in this lecture we will be studying about the arithmetic and geometric increase method. So with the one solved example, we will be able to understand how we estimate the future forecasting of the population growth. The following is the population data of a city available from past census record determine the population of city in 2021 by arithmetic increase method, geometrical increase method. In 1941, that city had the population of 12,000 numbers. In 1915, 16,500. In 1916, 26,800. In 1971, 41,500. In 1981, 57,500. In 1991, 68,000. And in 2001, 74,100 people were living. Then we have to estimate what would be the population in 2021. So we will see first from with the arithmetical increase method. In this method, the increase in population from decade to decade assumed constant, means population from say year 1941 to 1951 will be almost equal to 1951 to 61. If it is a old city, so we assume what is the growth in the past decade, similar growth will be in the future decades also. So dp by dt, growth in the population with the time is constant, rate of change of population and k is constant. From the census data of past 3 to 4 decades, the increase in population for each decade is found, and from that an average increment is found for each successive future decade. This average increment is added. The future population Pn n decades is thus given by Pn with latest population P plus number of decades into average increase in population. Pn future population of the at the end of n decades, P present population, P is a present population, and I average increment for the decade. So we can have the solution for this. In the given problem, it is 1941 it was 12,000, 1951 16,500, 1961 26,800, 1971 41,500, 1981 57,500, 1991 68,000, 2001 74,100. We have to estimate for the 2021 as per the given problem. So from the 12th, from 1941 to 1951, increase in the population is 16,500 minus 12,000. So it has come 4,500. So B accordingly B average population increase is 4,500. Then from 16,500 to 26,800, it is 10,300 increase. From 26,800 to 41,500, it is 14,700 increase. 41,000 to 57,000, it is increase of 16,000. From 57,500 to 68,000, it is increase of 10,500, and from 68,000 74,100, it is increase of 6,100. So we can input these data in the formula which we derived in the previous slide. Pn is equal to the present population number of decades into the average increment. So this total we found that it is 62,100 increased in 6 years. 1, 2, 3, 4, 5, 6. So divided by 6, we found the average, means the value of I is 10,350. So present population is 74,100. Present population is in 2001 latest are present 74,100, and the number of decade from the 2001 to 2021 is 2000, 2011 and 2021. That's 20 years divided by 10. So this will be 2 decades. So number of decades is 2, and the increase in the population 10,350 average increase of the population in the subsequent years. यदि हम इसको निकाल लेते हैं difference and then we add up and divided by the number of years, then we get the average. So after getting the average, we input the average also. It has come 94,800 in the year. Forecasted population in the year 2021 is 94,800. So we need to design our all the components based upon this figure, then we have to go for calculate for the variations, maximum demand क्या होगा, peak demand क्या होगा. In the next slide, we will study about this. So in incremental increase method, geometric increase method for the population forecasting, this method assumes that population increases at constant percentage rate. At the constant percent, if the population increase is 10% between 1941 to 51, so there will be almost similar percentage increase in 1951 to 1961. This assume like this, and growth of population proportional to the existing population. If today is 1000, so after 1 year it will be 1100. It will be the proportional. The increase follow compound interest pattern. Formula for the increase method is Pn is equal to present population P, 1 rate of growth 100 and divide it to the power n. This is the number of decade. Pn population after decade or years. P present population are the percentage growth rate, n number of decade or years. By using this formula, we find the population growth in the 2021, which is in the question. So here we know in 1941 it was 12,000 and so on, 74,100 it is given in the problem. So there was difference between 12,000 to 16,500, 4,500, 16,000 to 26,800, 10,300 and so on. Then we estimate what is the percentage increase. Percentage increase for the 41 to 51 is 4,500 divided by 12,000 divided by 12,000 into 100. So we can calculate it. 4,500 divided by 12,000, that is 12,000 into 100. 37.5%. 37.5% growth from 1951 to 1941 to 1951. Likewise, we estimated the growth percentage from 51 to 61, it has come 62.42%. 61 to 71, 54.85%. 71 to 81, 38.5%. 81 to 91, 18.26%. 91 to 2001, 8.97%. Average increase, if we add up and divided by 6, it will come 36.75%. Generally, R value for the generally it is used the average only, but in the manual it has been given to use geometric mean. So to find out geometric mean, this is 6 root of 37.50 into 62.42 into 54.85 into 38.55 into 18.26 into 8.97. If we multiply this, we get the figure 810679633.71 to the power 1 by 6. If we take the root 1 by 6, the figure will come 30.53. Now population in 2021 will be the present population 74,100, 1 plus the rate of growth is 30.53, rate of growth in percentage 30.53 divided by 100, number of decade is 2, 2001 to 2021, 28 divided by 10, so 2. So solving it, we get 1,27,252.17, say 1,26,252 numbers. So in arithmetic mean we have seen we get 94,800, whereas in the geometric incremental increase method we got 1,26,250. So we use this for the future designing. With this we completed how to calculate future forecasting of a population for the water supply project. In next, what is the variation we will be studying about. Thank you.